Alright, now we move on to the second part of the transformer, which is called the referring of parameters. Now before we talk about all the parameters, let us zoom into this equivalent circuit of a practical transformer. Now ideal transformer, you remember, was just simply just primary coil and secondary coil, but a practical transformer actually consists of 6 other parameters. Okay, what are they? Okay, again, this is the full picture now. So this is a equivalent circuit of a practical transformer, the primary side and the secondary side. Now you must know the English word of all these parameters very well, because in the exam or even in the tutorial question, a lot of times the diagrams are not given, but they use English word to describe to you the parameters. Now if you recall our transformer, that consists of an iron core and the primary coil and the secondary coil, right? So R1 and X1, R1 and X1 comes from the primary coil, and R2 and X2 comes from the secondary coil, right? Now the resistance of the wires are called the primary winding resistance. So likewise in the secondary is called a secondary winding resistance. Okay, repeat: primary winding resistance, secondary winding resistance. And because it's an AC circuit, so you have reactance, right? This is called the primary leakage reactance and secondary leakage reactance. Okay, which do you think you are able to say it yourself? Primary winding resistance, primary leakage reactance, secondary winding resistance, secondary leakage reactance. Now what about these two who are in parallel? These two parameters are actually from the iron core, right? And this is called the core loss resistance, and the magnetizing reactance, So always remember that this parallel structure is from the iron core, whereas the series elements here are from the copper wires, primary winding and a secondary winding, right? So this is called the parameters. Now what we are going to learn is that we will be able to simplify circuits by referring parameters, moving parameters to here or move these parameters to there, right? Originally is your primary side has these 4, secondary side has these 2. Okay, so now the next thing that we want to learn is to refer parameters. Alright, if I were to refer all parameters to primary side, if I want all the parameters to refer to the primary side, in other words, to say that I want R2 and X2 to go away. I do not want it to be here. Alright, I want it to be adjusted and bring over here. So the equivalent value then is called RE1 and XE1. Okay, now what is in the RE1? RE1 would have the original R1 together with the adjusted R2. So RE1 is equal to R1 plus A square R2. For you to bring over R2 to the primary side, you have to adjust it by multiply by A square. Okay, and what is A? If you can still remember, the A is the turn ratio, V1 over V2. So when you bring over R2, you must multiply by A square. Likewise, XE1 is equal to X1 plus A square X2. So what you learn in this second point is that when you want to refer parameters to the primary, you multiply by A square. What was originally here remains unchanged, like these 2, they remains unchanged. That's what it means by referring parameters to the primary side. Okay, summarize. To bring things to a primary, you multiply by a squared. Okay, so now we learn how to refer parameters to the secondary side. Now to refer parameters to the secondary side, this time, all the things in the primary must go to the secondary. So this is the primary side. If you recall what's in here, there was a parallel structure here, right? And the R1 and X1, right? So now we have to move it to the secondary side. Okay, so this will be called RC2 and XM2. They are called 2 now because they are on the secondary. Just now was RC1, XM1. I move it to the secondary, I call it RC2 and XM2. And here is called RE2 and XM2, right? Oh, sorry, XE2. E stands for equivalent, means it's a combination of both primary and secondary. Now, to calculate RE2, it will be the original R2. Remember, original there was an R2. Your R1 now has to be brought over. To bring over R1, you divide by A squared. Okay, when we refer parameters to the secondary, things that move over, you divide by A squared. And again, what is A? A is the turn ratio V1 over V2, right? Okay, so do you think you can guess what is XE2? That will be X2 plus X1 divided by A squared. Okay, and RC2 equal to RC1 divided by A squared. XM2 equal to XM1 divided by A squared. So the tricks of the formula is that you either multiply by A squared or you divide by A squared. Okay, so that's called refer parameters. Now let's practice you on the English word. How would you say this in English? The equivalent winding resistance, the secondary equivalence winding resistance, secondary equivalence leakage reactance, secondary core loss resistance, right? And the secondary magnetizing reactance. So that is called refer parameters to the secondary side. Now let us practice on numbers, because basically when we do numbers, we are more familiar with the concept. Right, so if I have an exercise, okay, and I have a circuit here, I have this, I have this, I have this. Okay, and this is the 10 kVA transformer, 600 to 900 volt transformer. Okay, and here is equal to 1.2 ohm, this R1, and X1 is equal to 1.8 ohm, right? And here is equal to 1.04 ohm, and here is 1.002 ohms. Okay, and that is R2 and that's X2. Alright, and I have this core loss RC1 and XM1. Say here is 140 ohms, and here is equal to 90 ohms. Okay, so it's 600 volt, 900 volt. Right, part A. If you are asked to refer to calculate RE1, yeah, and XE1, do you know that you are actually asked to move this over? So RE1 is equal to R1 plus A squared R2. XE1 is equal to X1 plus A squared X2. So R1 is 1.2, and what is A? Turn ratio, 600 over 900 square multiply 1.04. Right, and the formulas are given in the exam, these two. XE1 will be equal to 1.8 plus A square multiply 1.02. Right, so that's what it is. So if you are asked to draw the diagram, of course the diagram becomes like this. The parallel structure no change in value, but this change. Right, and that's your RE1 and XE1. This is the RC1 and XM1. Alright, so that's called referring parameters to the secondary side. Okay, if I call this exercise 1. Okay, right, exercise 2. Okay, let's try another exercise. Exercise 2, same question, but this time I want it to be referred to the secondary side. Okay, I've asked you to find part B, RE2 and XE2. Okay, RE2 and XE2 and RC2 and XM2. So here I want these parameters to all refer to that side. Right? So the formula is R2 plus R1 divided by A square, X2 plus X1 divided by A square, RC1 divided by A square, XM1 divided by A square. Right? So that is equal to 1.04 plus 1.2 divided by A. Who is A? Remember 600 divided by 900? Right? And here will be X2 is 1.02 plus 1.8 divided by 600 over 900 squared. And here will be 140 divided by A square. And this will be equal to 90 divided by 600 squared. Okay, so that is called referring parameters to the secondary side. Okay, and if you are asked to draw the diagram, then the diagram will be this all disappear and they all move to the secondary side. So if you were to ask to draw the diagram will become like this. Primary side, everything disappeared. Secondary side. So this is called RC2, XM2, RE2, and XE2. Now, of course, there are times that you are asked not to refer everything. If you are just asked to refer these two, then these two can stay here. So you read the questions according to what the question wants. Which are the things that you are asked to refer, right? And this is called the refer the parameters. Now, before I end the refer the parameters, I want to tell you another way of naming these parameters. Now, our traditional way of calling the parameters, we use 1 and 2, right? We call this R1, we call this X1. Secondary side, we call it R2 and X2. 1 denotes the primary, 2 denotes the secondary. Right? Okay, let's try again. Call loss resistance, magnetizing reactance. Primary winding resistance, primary leakage reactance. Secondary winding resistance, secondary leakage reactance. Right? Now, what I want to tell you is that if I were to tell you that this is a low voltage and high voltage coil, then instead of calling 1 and 2, is it alright if I call low voltage, low voltage, low voltage, low voltage, and then here I call it high voltage, and I call it high voltage? Yes, can be done that way. So the nomenclature is either the 1 or 2, or we use the LV and HV. Alright, so if things that's on the LV side, we call them the LV. Things on the high voltage side, we call them HV. Right? So now let's say I want RELV. That means I want the equivalent. Remember the combination? So this is my RE1, because this is my 1, right? I want RE1. So that will be what? if you recall, will be my RLV plus A square RHV. Remember? R1 plus A square R2. Okay, and I want XELV, that's XLV plus A square XHV. Can you see the parallel between 1, 2 and this LVHV things? Should be, right? Okay, let's try referring things to the secondary. So if I want things to refer to the high voltage side, then I'll say REHV and XEHV. So that will be RHV plus RLV divided by A square. Right? And here will be XHV plus R plus XLV divided by A square. Right? Now, so I have put this over. How about these two? I also have to refer them, and that is called RCHV and XMHV. That will be equal to RCLV divided by A square, and that will be equal to XMLV divided by A square. Okay? What I just illustrated to you was just that the way they we named them. Instead of using 1 and 2, we can also use the LV, low voltage, or high voltage notation. Right? And that is called referring parameters. Now, to sum up, the second section of transformer is about referring parameters. How many parameters are there altogether? There are 6. What are they? R1, X1, R2, X2. The two-parallel structure, RC1, XM1. Not good enough to can call them 1 and 2, but you must also be able to spell them out in English words. Primary winding resistance, primary leakage reactance, secondary winding resistance, secondary leakage reactance, core loss resistance, magnetizing reactance. When you refer things to the primary, you multiply by A square. When you refer things to the secondary, you divide by A square. Right? And that is all for the second part.